What truly makes up our reality? Is it the solid objects we can touch and feel, or the distant stars that glitter in the vast expanse of the cosmos? We often perceive our universe as a collection of things. However, this essay proposes a different, perhaps more fundamental, viewpoint. We will explore the idea that reality in its most basic form is not built from objects, but from the very concept of difference. Imagine a state where no distinctions exist. It would be an undifferentiated void, a nothingness where existence itself cannot take hold. Consider the simplest contrasts you can imagine: light and dark, hot and cold, silence and sound. These are all fundamental differences, distinctions that allow us to perceive and interact with the world around us. Without these differences, our experience would be a monotonous blur, devoid of feature or form. The concept of difference itself is the starting point, the primary condition for anything to be. This notion suggests that the universe is, at its core, an intricate web of these distinctions, constantly interacting and evolving. This perspective isn't merely a philosophical exercise or a playful thought experiment. It has profound implications for how we understand the physical laws that govern our universe. If differences are indeed primary, then many phenomena we study in science, from the smallest subatomic particles to the grandest cosmic structures, can be seen in a new light. For centuries, our scientific quest to understand reality has largely focused on identifying its fundamental constituents. We have spoken of atoms, then of subatomic particles like electrons and quarks. We have described the universe in terms of matter and energy, fields and forces. These concepts have served us incredibly well, leading to astonishing technological advancements and a deeper appreciation of the cosmos. But what if matter and energy are not the ultimate bedrock of existence? What if they are, themselves, manifestations of something even more fundamental, something that allows them to be distinct in the first place? This is where the concept of differences takes center stage. Imagine trying to define a particle of matter. To do so, it must be distinguishable from the space around it, from other particles, or from a state of nothingness. Its properties, its mass, its charge, its spin, are all characteristics that differentiate it. Similarly, energy, in its various forms, represents a difference in temperature, a difference in potential, a capacity to induce change. Without an underlying framework of distinguishability, the very notions of particle or energy state would lose their meaning. Differences, therefore, are not just passive descriptors, they are the active ingredients that make the existence of matter and energy possible. This shift in perspective, from a reality of things to a reality of differences, invites us to rephrase many of our deepest questions. Instead of asking solely, what is the universe made of? We might also ask, how do distinctions arise, persist, and organize themselves to form the complex structures we observe? It's about understanding the rules of the game by first understanding what makes any rule possible, the ability to differentiate. By viewing reality as a dynamic, evolving network of distinctions, we can begin to piece together a more cohesive picture of how everything, from the quantum foam to conscious thought, is interconnected through this fundamental principle. Humanity's journey to comprehend the universe is a story as old as consciousness itself. From ancient civilizations charting the stars to modern physicists probing the quantum realm, we have relentlessly sought to make sense of our existence. We build models, formulate theories, and tell stories to explain the world around us and our place within it. This essay and the ideas it explores is part of this grand, ongoing human endeavor. It is an attempt to look at reality through a slightly different lens, one that focuses on the fundamental role of distinctions in shaping everything we know and everything we are yet to discover. The idea that reality is fundamentally a web of differences might initially appear abstract, perhaps even counterintuitive. We are so accustomed to thinking about the stuff of the universe, yet this concept holds remarkable power. It acts as a unifying principle, allowing us to draw connections between phenomena that might otherwise seem entirely separate. Consider it like finding a common ancestor for diverse species in biology. Here, we seek a common root for the diverse phenomena of physics and even philosophy. This shared ancestry lies in the simple yet profound act of differentiation. In the subsequent parts of this essay, we will systematically pull on the various threads that emanate from this central idea. We will explore how the relentless increase of entropy, which dictates the arrow of time, can be understood as a natural consequence of differences tending towards more probable, less distinguished states. We will venture into the enigmatic world of black holes, questioning how they process differences and what this means for the conservation of information. Prepare to unravel reality, one difference at a time, and perhaps see the universe in a new, more interconnected light. What is entropy, in its essence? It's far more than a cluttered room, it is the universe's inherent tendency, a deep drive to blur all distinctions. Our reality, we propose, is built from differences. Entropy is the gradual fading of these forms. Sharp, clear distinctions are quite special. They require a specific, unlikely setup. Over time, this inherent sharpness softens. This softening is the true heart of entropy. Why does this blurring universally happen? Picture a detailed sandcastle on the shore. It stands apart, meticulously ordered. Its structure shows very sharp differences. Sand versus air, defined shape versus flatness. Yet countless ways exist for sand to just scatter. A slight breeze, a gentle incoming wave. We all sense time's relentless march. Yesterday is past, tomorrow is yet to be. But why this unwavering one-way progression? Why does time possess this specific direction? Physicists term this the arrow of time. Its true origin has been long debated. Is time an actual river, constantly flowing, or is its fundamental nature quite different? Our framework of differences offers new clues. It helps redefine our idea of time's flow. Time's arrow emerges directly from entropy. It arises from this persistent blurring of differences. Imagine you are watching a film run backwards. Spilled milk leaps neatly back into a glass. A shattered vase perfectly reassembles itself. These reversed scenes feel deeply unnatural. Why? They show differences spontaneously sharpening. Order appears to increase all on its own. This directly defies the statistical natural drift. Scientists operate with a powerful rule. This is the second law of thermodynamics. Its core statement is deceptively simple. Total entropy in isolated systems always increases, or in the very best case scenario, it stays constant. Critically, it is understood to never decrease. This principle is a cornerstone of modern physics. It explains why perpetual motion machines fail. It dictates engine efficiency and stars' final fates. Its implications are both cosmic and profound. Can we truly understand this vital law, perhaps by using our ontology of differences? Yes. From this unique viewpoint, the second law transforms. It is no longer an arbitrary, imposed decree. It's not merely an axiom to be accepted. Instead, it naturally follows from difference dynamics. Black holes stand as cosmic titans of mystery. They are places where gravity reigns supreme. Matter is crushed to unimaginable densities. Our understanding of physics is stretched to its limits. What happens when differences encounter such extremes? If reality is woven from distinctions, what is their fate here? Do they get erased from existence entirely, or do they undergo a more subtle transformation? These questions probe the heart of information itself, and challenge our model of a reality built on differences. In our framework, a black hole is unique. It represents a local collapse of distinguishability. Imagine a region where differences can no longer be clearly told apart. This region is defined by its event horizon. The event horizon is a crucial boundary line. It is the ultimate point of no return. Differences that cross this threshold become inaccessible. They cannot be directly perceived by any interface. Any observer outside this boundary loses direct contact. The brilliant physicist Stephen Hawking changed our view. He showed that black holes are not entirely black. They should slowly radiate energy and particles. This phenomenon became known as Hawking radiation. Initially, this radiation appeared to be purely thermal. It seemed to carry no information about what fell in. This posed a monumental problem for physics. If information is destroyed, quantum mechanics is violated. A core principle states information must be conserved. Thus, the black hole information paradox was born. In our model of differences, Hawking radiation is key. It is the gradual restoration of differences, a slow leakage from the black hole's interface. But these differences are not restored in their original form. They reappear only at the level of subtle correlations. The event horizon acts as this crucial interface. It is the surface where this subtle leakage occurs. The radiation is not just random noise, it carries faint echoes, faint whispers of what was lost. These whispers are encoded in the patterns of emitted particles. The paradox hinges on this apparent loss. The original detailed form of the differences disappears. A star, a book, an astronaut, their specific structures vanish. Yet, the underlying information, the essence of their differences, must persist. How can these two seemingly contradictory facts be true? The resolution lies in how information is preserved. It is the correlation between differences that endures. The specific arrangement might be lost to an outside observer, but the fundamental quantity of distinguishability is not. It's like knowing two dice were rolled, without seeing the exact numbers. This preservation of correlational information is vital. It means that, in principle, nothing is truly lost forever. The story of whatever fell into the black hole isn't erased, it is merely recoded into an incredibly complex form, a form that is extremely difficult to decipher. The black hole in this view acts as a cosmic scrambler. It is an ultimate information processor, not an information destroyer. The differences are transformed, not obliterated. They are woven back into the fabric of reality, albeit in a profoundly subtle and intricate manner. So, a black hole fundamentally recodes differences. It takes the distinctions that cross its event horizon, and transforms them into a new, unfamiliar format. The original form, the way those differences were first arranged, that specific configuration vanishes from direct observation. Consider a complex library falling into a black hole. The individual books, their pages, their words are gone. Their material structure is lost to the singularity. But the information they contained, the differences they represented, that essence undergoes a profound change in its encoding. This recoding process is subtle and profound. The information, the underlying distinctions themselves, are not erased. Instead, they are translated into a different form, a new language of reality, written on the event horizon. This aligns with the holographic principle in physics. This principle suggests all information within a volume can be represented as if encoded on its boundary. So, the black hole's event horizon becomes a vast storage device. It holds the recoded information of everything it has consumed, preserving the universe's ledger of differences. But how do we access this transformed information? It is not directly readable in the conventional sense. It becomes accessible, but only through interface effects. Hawking radiation is the prime example here. The subtle correlations within this escaping radiation. These correlations carry the imprints of the recoded differences. Decoding this information is an immense theoretical challenge. It is like trying to reconstruct a shattered mirror from only the faintest reflections seen in its dust. Yet, the principle remains. The information is there. This perspective aligns beautifully with modern physics. Many current hypotheses grapple with information in black holes. The holographic principle, string theory, and ADS-CFT correspondence. All explore how information can be preserved, not lost. They seek to reconcile gravity with quantum mechanics. Our model of differences offers a conceptual framework. It resonates with these advanced scientific explorations. It emphasizes that information, as a form of difference, is robust. It is a fundamental aspect of reality, conserved even in extremes. Black holes transform information, they do not destroy its essence. Our journey now leads us to a profound question. It is a puzzle that has captivated thinkers for ages. If reality is a vast deterministic web, what then? Where does our sense of free will fit into this picture? Are our choices genuine expressions of our own volition, or are they merely predetermined outcomes, illusions of control? This is the paradox we must now confront. The architecture of agency, how differences choose. How does freedom arise from complex differences? A key concept is a loop of differences. Imagine a system like a human brain as such a loop. It is a network of distinctions that can refer back to itself. This self-referential capacity is incredibly powerful. It allows the system to process information about its own states and interactions. This internal feedback is the foundation of genuine choice. Navigating determinism, the emergent bubble of will. The world is deterministic. Basic patterns follow unwavering rules. Free will fits within this framework. It emerges as a bubble of localized freedom. Complex systems carve out choices. This freedom is contextual, not absolute. It reveals the richness within determinism. A deterministic universe can contain genuine freedom. From simple distinctions to layered realities. How does a universe built from simple differences give rise to such staggering complexity? We see life in its myriad forms. We observe intricate economies and societies. These are not just random collections of basic distinctions. They represent entirely new levels of reality, each with its own unique characteristics. This remarkable transformation is known as emergence. It is the process by which primary fundamental differences organize themselves. They build upon each other layer by layer. This creates what we can call meta-differences, leading to phenomena far richer than their basic components. What exactly are these meta-differences? Think of them as differences about differences. They are patterns, relationships, and organizations that arise from simpler distinctions. Consider the letters of an alphabet. Each letter is a distinct shape, a primary difference. When these letters combine, they form words. A word is a meta-difference. Its meaning transcends the individual shapes of its letters. Words then combine to form sentences, which carry even more complex information. Each step represents a new layer, a new level of emergent meaning built from the distinctions of the layer below it. This is the fundamental architecture of emerging complexity. These new layers of reality possess fascinating properties. While they are undoubtedly built upon and conditioned by the lower levels, they are not fully reducible to them. You cannot entirely understand the concept of a story by only studying individual letters. The whole truly becomes more than the sum of its parts. New rules, new behaviors, and new kinds of interactions appear at each higher level. A living cell behaves in ways that simple molecules do not. A flock of birds exhibits patterns that a single bird cannot. This irreducibility is a hallmark of emergent systems, showcasing their novelty. The organization of differences into multi-layered networks is crucial here. It is not just a simple stacking of levels. Instead, imagine an intricate, interconnected web. Each node, each connection represents a difference or a relationship between differences. These networks are dynamic, constantly shifting and reconfiguring. It is within this complex interplay, this hierarchical structuring, that the true richness of emergent phenomena comes to life. The ability of differences to form these sophisticated networks is the engine that drives the universe from simplicity towards astonishing complexity, creating the diverse tapestry of existence we observe all around us. What fundamental mechanism drives this captivating process of emergence? The engine of complexity is fueled by an increasing capacity to distinguish. Each new level of complexity grants the system a new set of eyes. They become stable and self-perpetuating, forming the building blocks for further complexity. These self-sustaining patterns are the new fundamentals for the next layer. The capacity to form and maintain these meta-patterns drives the emergence of intricate realities. Let us consider some tangible examples of this emergence in action. Life itself is perhaps the most profound and awe-inspiring emergent system we know. From non-living chemicals, life emerged. Complex organisms evolved, with new rules of genetics and biology. Look also at human economies. Individual interactions create vast economic systems. Consciousness and societies are emergent phenomena too. New levels of reality surface naturally, adding to the richness of existence. The quantum world is a realm of profound strangeness. Particles can exist in multiple places at once. They can spin in opposite directions simultaneously. This is not a metaphor, it is a measured reality. Before observation, it remains undefined. It exists only as a range of possibilities. This state is known as superposition. Reality at this level is a dance of pure potential. The wave function describes these possibilities. It encapsulates all potential states of a quantum system. Before observation, the system is all these potentials together. This is the fundamental nature of quantum reality. What does it mean to observe in this quantum context? It is far more than just passively looking at something. Observation is an active process, activating a difference. It makes one potential distinction real and concrete. The observer interacts with the system, fixing a chosen difference as a fact within reality. This transition from quantum possibility to classical actuality is fundamental. The observer's structure engages with the wave function's potentials. This interaction changes the system, collapsing the wave function into one single outcome. Why does the wave function collapse to one outcome? The answer lies in coherent decoherence. The observer's structure processes and stabilizes information. It selects a self-consistent version of reality. This makes observation meaningful. Observers actively shape what becomes real. Our journey through the fabric of reality reveals a profound truth. Everything is woven from the concept of difference. This idea is the bedrock of existence. Entropy and time blur these distinctions. Order seeks disorder, a statistical certainty. Differences tend towards indistinct states. This thread connects us to the universe's flow. Black holes recode, not destroy information. Information endures imprinted on the horizon. Complexity arises from simple differences. Free will emerges from this complexity. Quantum observation collapses potential into reality. Entropy, information, and free will are intertwined. They form a coherent story of difference dynamics. This is the great tapestry of the universe. What is the ultimate takeaway from this exploration of reality? Reality is fundamentally interconnected, a dynamic, evolving tapestry woven from myriad distinctions. This ontology of differences offers a unifying lens. It reveals a common thread through diverse phenomena. From cosmic structures to the human mind, the universe is a vibrant process of differentiation and transformation, a cosmic dance of becoming. This perspective challenges us to see anew. We are active agents in this grand unraveling of reality, co-creators in unraveling its deepest mysteries. The quest for understanding is humanity's greatest adventure.